Hello, everyone. Uh, Today, our goal today is to identify and interpret key characteristics of functions. And what I asked you to do is, as your starter, what you should have already done is to go out there to Delta Math, and it's deltamath.com. If you already have an account, you're just going to make sure that you add me as a teacher. Click Algebra 2 2021, and just make sure you're working on the Unit A Algebra 2. There's 4 or 5 things out there. They're over functions. When you are finished, it'll save automatically, and all this is interactive practice. So make sure you spend some time on that. What I'm going to focus in on is this assignment. We're going to do most of this together. And what it is if you see a function, you should start recognizing characteristics. And so I've already opened this up. That's what this tab is for. Okay, so a lot of this is going to be review. Let's see, waiting room. We say that the domain of a function is all the inputs. It's all the allowable inputs. So here I have a graph, and domain is basically the axis. Okay, so when I look at this graph, I would say the domain is all real numbers. Why? Because it goes to the left forever, and it goes to the right forever. So the domain would be all real numbers. And the way you say all real numbers is you put negative infinity to positive infinity. This is called interval notation. So this is another way to say all real numbers. Now the range is not all real numbers. The range is all the allowable y values. And we can see that on the y, it comes down, it reaches 0, and it goes back up. Okay, so we would say this goes up on the left, up on the right, and notice it doesn't ever make it down here. So when I'm writing that for the y, I would say 0 and up. Or I might say y is bigger than 0. Y is bigger than or equal to 0 is the more exact way. Or this is called interval notation that says start at 0. The bracket here means include 0, and then go up forever. So there's many ways to write that. The way that you're used to seeing this is y is bigger than or equal to, and I used to know how to write that on here. I know there's a way. Y is bigger than or equal to 0. I wish I remembered how to do that. There is a way. Okay. Probably looks better like this. I'll just do it like this for now. There. Yeah. So you're used to seeing it written like that with the greater than symbol with the equal. So all that means is 0 and up. Okay, that's one way to say it. So that's domain and range, and you should have seen that in Algebra 1. So when I look at this picture, D stands for domain, R stands for range, and this means what is the value at 0. Now this is review from last class. So when I input a 0, what is the y? So here's 0. I go up to the y and I get 3. So this part's easy. That's just 3. On this graph, f of 0, so I go to 0, what's the y? Y is 4. Okay, so that's the easy part. Now, when you're doing this, we're going to read left to right, and so it's important to remember that we call all the way to the left as negative, and I think I remember, oh, that didn't work. I can't remember how to do the keyboard shortcut. I had it a second ago. I was trying to put in infinity. Infinity, keyboard shortcut, Alt 236. And you guys don't have a number pad on your Chromebook, so it won't work, but Alt 236. There we go. So unfortunately, you guys can't do that. But if you have a number key, you could do shortcuts. And then over here, we call that positive infinity. So negative to positive. And then down here would be negative infinity. And up here, positive infinity. So when I'm talking about domain, I'm talking left and right. And I notice that it goes to the left forever and it goes to the right forever because this keeps going. So the way I write that in interval notation, meaning all real numbers, is I just put negative infinity to infinity. So that's what I would put here. I'd put negative parenthesis, negative infinity to infinity. A little bit, make it easier to see. Change that a little bit. There we go. That's how you write interval notation. Now that's domain. Now range we have to say up and down. So it starts at negative infinity and then it goes all the way up to and it stops at 4. So it actually stops at 4. So to write that, I would say negative infinity to 4. That's the domain and that's the range. Okay. Another way you could write this is all real numbers. The way you could write this would be y is less than or equal to 4. But I'm trying to get you used to interval notation. All right, over here, and so I don't have to do this again, I'm going to copy these over. There we go. So what is the domain? It goes to the left forever, looks like a cycle, and it goes to the right forever. So domain would be the same thing, all real numbers. I guess it won't let me copy. That's fine. So I got negative infinity to positive infinity. All real numbers. Now the range, the lowest it gets looks to be -4. And the highest it gets looks to be 4. And it cycles between. It starts off at 0, goes up to 4, goes down to -4, goes up to 4, goes down to -4, and it looks like it continues that pattern. And the way I would write that, you start at the bottom. So in interval notation, we would say from -4 to 4. And that's how you read that. It means the lowest value is -4, the highest value is +4. Let's see. Now there's 3 key things I want you to understand from this section, and it's the difference between increasing, decreasing, and constant. So like on this picture, see how it's going up? It's going up, we read left to right, so that's why we say it's increasing. This one is going down, decreasing, still going down. It's going down everywhere. Okay, so it's decreasing the whole time. And this one is staying constant. It's not changing values. It's just going in a constant rate. So those are 3 words you'll see a lot. So on here, state the interval on which the graph is increasing, decreasing, or constant. And assume the lines of the function continue to negative and positive infinity. So assume that these have arrows on them. Okay, so it doesn't stop there. Okay, so when is this increasing? Increasing would be from here, increasing to there. That's increasing. And so what I would say is from 0 to 2. Okay, so it starts at 0 and then it stops increasing at 2. And the way I write that interval notation is I say 0 to 2. Now decreasing. I meant to put that in black. Decreasing, I better not use blue, it's the same color. Decreasing would be, it goes up forever. So decreases, 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 decreases. And then right there at this point, the slope is actually 0, and then it goes back up. So it's decreasing from negative infinity to 0. And also, it's decreasing from here all the way forever, and this goes forever. Okay, they don't tell us that, but they said in the instructions to assume that. So at 2 to infinity, so starting at 2 and going forever, it also decreases. Okay. And if you don't have that infinity symbol, remember you could draw it by hand. You know, you could just draw it yourself. Okay. All right, so that's when it's decreasing. And then I wouldn't really call it constant anywhere. I mean, technically, I guess at the max and the min is kind of constant, but we'll say we'll just say no constant areas. Some people might argue that at the minimum and the maximum, there's a constant. All right, next one. When are we increasing? So when are we increasing? That would be, looks like it from here to here. And remember, they said assume the lines continue to negative and positive infinity. So this actually goes on forever. So when's it increasing? From negative infinity until you get to -1. When's it decreasing? It's not decreasing anywhere. So no decreasing intervals. I should probably change that to intervals. It just sounds better. Now, when's it constant? It's constant from here, not going up, not going down, not going up, not going down. And where does that start? That starts at -1 and goes forever. This keeps going forever. So I would say from 1 to infinity. And I just realized my mistake. Technically, I guess you could include brackets there. See, at 1, we'll just leave them as parentheses for now. I can see why it could be both ways. All right, now when we go down here, we have another picture here. So indicate the intervals of which f is increasing. Increasing would be from here to there. Okay. And we also have increasing from here to there. And then decreasing we would have from here to here, and then here to there. Okay. So why don't you just take a second and see if you can't figure out what those would be, and I'll be back on here in a second. All right, I'm back. Sorry, I wanted to see how your district tests put these, and they don't use interval notation, even though that's better. They use the less than or greater than symbols. So like for here, you would say it's increasing from 0 to 2. And so the way you would write that is you would say x is bigger. Well, you'd say 0 is less than x is less than 2. Okay, so that's the way you're used to seeing it. Okay, but these mean the same thing. I'm going to continue to use interval notation. So when is it increasing? It's increasing from -2 to 0. And from 3, and does that continue forever? It looks like it stops there. From 3 to 5. Okay, see how it has an open circle? That means it stops right there, and has a point there, that means it stops. So we're not going to use the infinity symbol. And then when is it decreasing? Would be from -3 to -2. And from 0 to 3. Okay. And we don't use brackets because technically right here, it's not increasing or decreasing. Once you get to 3, it's kind of at 0. So you can kind of argue it's constant, but not really. So that at 3 is when it goes from down to back up. So we're not going to include 3. Now state the domain and range and interval notation. Domain, because it has a period here, that means that it includes -3. Here, that's an open circle. That means it does not include 5. So all the allowable x values, we would say from -3 to 5. So the domain is from -3 to 5. And since this is a filled in, we include that. So the way we say we include it is we use a bracket. Now, let me see if I can find my bracket. There we go. Nope, not that one. There we go. So that means that includes -3, but it does not include 5. And notice 5 is an open circle. For range up and down, looks like the lowest value is -5, and it goes up to 0. So I'd say range has -5, including -5, and it goes up to 0, including 0. Okay, so that is the domain and the range. There's a huge gap in here. But what I want you to do for your practice is, what is the domain of f? Notice that these do have arrows. What is the range of f? Notice this is the f function. What are the x-intercepts? We didn't talk about that, but remember x-intercepts are where it crosses the x-axis. That'd be this point and this point. And then, of course, the y-intercept would be where it crosses the y right here, so that point. Intervals on which f is increasing, intervals on which f is decreasing, we talked about all that. And then intervals for x for which f of x is less than 0. So remember, f of x is like a y. So when is this less than 0? In other words, when is it underneath the x-axis? So, oops, this part means that would mean from here to here, that's less than 0. And from here to here, that's less than 0. So that's what that part means, okay? And notice that says less than or equal to, so you'll use brackets. Then find f of -2, that's review from last class. And then the values of x for which f of x is 0, that's another way of saying what are the y-intercepts or x-intercepts. What are the x-intercepts? So that is all I have for today. Thank you guys for coming. I will end the video right here.